Hello everyone, welcome to my class. Today we are going to discuss some more concepts related to heat energy. Okay, so we'll start the class with boiling. See, you might have heard the word boiling in physics many a times, isn't it? Boiling point, boiling of water, and etc. So students, we will discuss about the reasons behind boiling. How does it happen? What happens with the heat? What happens with the temperature? And many more. Okay, you might have boiled water by yourselves, or you might have seen water boiling on a gas stove or a heater. Okay, what you might have seen over there. See, when we put water in a container and put it onto the gas stove or heater, and after some times you might have seen bubbles on the surface of water. This is actually the boiling process of water. Water boils when we supply heat energy to water. The temperature of water rises, and the temperature when it reaches 100 degrees Celsius, water starts to boil. That is why 100 degrees Celsius is called boiling point of water. Okay, 100 degrees Celsius is the boiling point of water. Students, just think about it. We have been supplying heat energy to water continuously, and it has reached the temperature 100 degrees Celsius, which is the boiling point of water. What will happen with the temperature? Whether it will increase or not. So let us now discuss the boiling process in detail. Okay? Students, let us now discuss process of boiling step by step. Let us consider the boiling of water. Water, as we know, is a solution, isn't it? There are many salts dissolved in water. Gas is also dissolved in water. So what happens when we provide heat energy to water? The temperature rises and the solubility of gas reduces on heating. Why? Because solubility of gas is inversely proportional to temperature. That means when temperature rises, solubility falls. So whenever water gets heat energy and the temperature rises, its solubility reduces. Then bubbles of gas are formed in the liquid. Okay? Solubility reduces and the gas whichever is there inside water, they form bubbles. Evaporation of water molecules from the surrounding causes the bubbles to become filled with saturated vapor. Saturated vapor will be formed when the evaporation process will be there in water molecules. Then what happens? Pressure of bubbles increases with increase in temperature. See, we are providing heat energy continuously. So rise in temperature is a continuous process. So whenever temperature rises, pressure of bubbles increases. So students, what happens then? At a certain temperature, the pressure of the saturated vapor inside the bubbles becomes equal to the pressure exerted on the bubbles from outside. When we provide heat energy, temperature rises, isn't it? And at a certain temperature, what happens? The pressure that is of the saturated vapor inside bubbles, they become equal to the pressure exerted on the bubbles from outside. There is a pressure inside the bubble and pressure is also being exerted upon them from outside. So when they become equal, then what happens? These bubbles rise rapidly to the surface and collapse. When they are equal, then the bubbles tend to rise to the surface. They rapidly rise to the surface. As you can see during the boiling process, the bubbles from the bottom of the container, they rise to the surface. And what happens then? At the surface, they collapse. And when they collapse, the vapor that is inside the bubbles, that is released to the air on the surface. So this is the process of boiling. Conversion of liquid to gas or vapor. Process of boiling has happened at a certain temperature when the pressure of the vapors inside the bubbles is equal to the atmospheric pressure. That means that is the temperature where the phase change happens. So that particular temperature, when the phase change happens, remains constant till the time all the water inside the container goes to their gaseous state and the vapors are released to air. So the temperature at which boiling process happens is called the boiling point, and boiling point of water is 100 degree Celsius, as we know. Okay. So students, as you have discussed the process of boiling, what should be the definition of boiling? Definition of boiling states that boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature at a given pressure. Okay, this temperature is different from liquid to liquid. Can we say that boiling point and evaporation are different? In our earlier classes, we have discussed about evaporation, and we know that evaporation can happen at any temperature. It doesn't have a fixed temperature, but boiling happens at a certain temperature. That is the boiling point of that particular liquid. Okay, students, as we have discussed in the boiling process that heat energy is continuously provided to liquid, and when it reaches the boiling point, the temperature doesn't change. Actually, that heat is utilized to change the phase from liquid to gas. Students, we have discussed in the boiling process of water that heat energy is continuously provided to water. It reaches up to 100 degrees Celsius. Then the phase change happens. But we are not stopping the supply of heat energy. So why does the temperature not increase? Where does this heat energy go? The heat energy is utilized in phase change of water from liquid to vapor. And this heat energy, which is utilized in the phase change of liquid to vapor, is called latent heat of vaporization. Okay, so how can we define latent heat of vaporization? Latent heat of vaporization can be defined as the heat energy required to change the phase of 1 gram of water to vapor. Okay, if there is 1 gram of water and we provide heat energy to it and it goes to its gaseous state, that is vapor, so the amount of heat energy that we supply to 1 gram of water is called the latent heat of vaporization. Okay, so students, if we provide Q calories of heat energy to a body of mass m, so latent heat of vaporization will be Q by m. Okay, Q by m, and it is represented with capital letter L. So L is equal to Q by m, when L represents the latent heat of vaporization, Q is the heat energy that is provided to the liquid, and m is the mass of the liquid. So what would be the unit for latent heat? See, SI unit of heat energy is joule, and that of mass is kg. So joule per kg will be the SI unit for latent heat of vaporization, and for CGS unit, the SI unit of energy is calorie, and that is of mass is gram. So calories per gram. So calories per gram is the CGS unit for latent heat of vaporization. Okay, students, another point to remember is that boiling point of water, as you know, is 100 degrees Celsius. So when we convert it to SI unit, that is Kelvin, that is 373 K. Okay, and the latent heat of evaporation for water is 540 calories per gram. This you need to remember. Okay, and it might help you in many ways. Okay, students, let us now discuss about melting. Melting is nothing but the phase change from solid to liquid at constant temperature. Okay, as boiling happens at a constant temperature, same way melting also happens at a constant temperature. So let us now discuss about the melting process of ice. Students, if we keep ice cubes in a container and put a thermometer inside, we will find that the temperature is either 0 degree or below 0 degrees Celsius. Okay, and if we provide heat energy to ice cubes, what will happen? We will see that mercury level rises up to 0 degrees Celsius if it was below 0 degrees Celsius initially. But what happens at 0 degrees Celsius? Ice starts to melt and it will form water. So whether the temperature increases, whether the mercury level rises in the thermometer, no. We will observe that the temperature stays at 0 degrees Celsius till the ice cubes melts into water. Okay, so this is the process of melting which happens at 0 degrees Celsius and it is called the melting point of ice. Okay, so how can we explain the process of melting? We can go step by step that heat energy is provided to ice cubes which increases the internal energy of the molecules of ice. Okay, whenever the molecules gain energy, they tend to go away from each other because they gain some kind of kinetic energy. That is why the bond between them weakens and that breaks at a some time. So the molecules, the H2O molecules of ice, they break and they go away from each other and ice melts to form water. This is the process of melting which happens at 0 degree Celsius. So 0 degree Celsius or 273 Kelvin is the melting point of ice, and this process of phase change of solid to liquid is called melting. Okay, so students, melting can be defined as the process of phase change from solid to liquid at a constant temperature. Okay, and what the temperature is called, that is the melting point. Okay, hope you understand. Students, the heat energy that is required to change the phase from solid to liquid is called latent heat of fusion. Okay, and how can we define it? The heat energy required to convert 1 gram of solid to completely to its liquid state is called latent heat of fusion. For ice would be 0 degrees Celsius or 273 Kelvin. Okay, students, if there is a solid of mass m and if the energy required to convert 1 gram of solid into its liquid state is Q calories. Okay, so the latent heat of fusion for that solid will be, which is dependent by L, Q by M. And as we have already discussed, SI unit would be joules per kg and CGS unit would be calories per gram. Okay, and latent heat of fusion for ice is 80 calorie per gram. You just need to remember this. It is the latent heat of fusion for ice. Okay? Students, let us now discuss about freezing. You might have observed that in winter season, coconut oil goes from its liquid state to solid state. You might have also observed that when we keep water in a freezer, it freezes to ice. Why does it happen? During the freezing of water, which takes place at 0 degrees Celsius, water loses its internal energy, thereby going to its solid state. So when it loses energy, it loses temperature. Isn't it? We have already discussed about the relationship between kinetic energy and temperature. So the process of conversion of liquid to solid state is called freezing. Okay, so let us now see how we can define freezing. Okay, so students, freezing can be defined as the process in which a substance in liquid phase changes to solid phase by losing some of its energy. In case of water, freezing takes place at 0 degrees Celsius and at 1 atm atmospheric pressure. Okay, so what happens then? At 0 degrees Celsius, water loses energy and goes to its solid state and becomes ice. So this is the freezing of water. Okay, but have you ever thought about the volume of water when it changes to its solid state, that is ice? Does it change or does it remain constant? Let us now discuss about it. To understand the change in volume of water when it goes from its liquid state to solid state, we can do an activity at home. What we need to do? We need to have a small glass bottle and fill it completely with water. Then we need to tight its lid so that no leakage of water would be there. And when we keep it inside the freezer to freeze and take it out after some time, what happens? The glass bottle breaks. Because the amount of water that was in the bottle has not changed. There is no other way that water can go inside the bottle. So the main thing that makes the glass bottle break is the volume of water. Water expands on freezing. That means when the expansion of water happens, volume of water increases so that it needs some way to go out. That is why when water goes to its solid state, that is ice, the bottle breaks because it doesn't have more space inside, it needs to go out. So the concept that we learn from this activity is that water expands on freezing. Okay, water expands on freezing. That means volume of ice is greater than volume of water. Fine. Students, we have discussed that volume of water increases when it goes to its solid state, that means it forms ice. So what happens to the density? We know that density is inversely proportional to volume. Okay, density is inversely proportional to volume. We can understand that the density of ice has to be less than that of same amount of water, isn't it? Because on freezing, volume of water increases. Okay, we have come to this conclusion. So if volume increases, density decreases. That is why density of ice is less than that of water. Okay, hope you understand. Students, today we have discussed about various concepts related to boiling, melting and freezing. Hope you have understood everything clearly. If not, please watch the video again and go through your books. I hope you understand everything very clearly. Okay, just remember that to learn something properly, you need to revise it again and again. Okay, so keep revising, keep practicing, and most importantly, keep smiling.